Good morning friends. After the discussion of the photoelectric effect, today we are going to discuss about the experiment performed by the different scientists and what are the observations of these scientists. First, what is the Hertz observation, and we have to explain in short why the concept of the photoelectric effect is obtained. After that, the two scientists more, Lennard and Holweg, also performed the experiment of photoelectric effect, and their observation we are going to discuss. First, what is the Hertz observation? Explain in short. Actually, the Hertz is not performing the photoelectric effect. He is producing the electromagnetic waves. So inside he found that the electrons are also emitted due to the incident of ultraviolet light. Right? So here we are going to discuss only what he found in very short sentences. Hertz observation. Explain in short. Okay. Now photoelectric effect was first observed by the scientist named as Hertz. How the Hertz found the photoelectric effect? So Hertz made experiment investigation of production of electromagnetic waves. Electromagnetic waves by means of spark discharge. Already we discussed about how the electromagnetic waves are produced in chapter of electromagnetic waves. Right? Okay. When the discharge takes place in a discharge tubes, at the time the electric and magnetic field, that means the atoms or the particles is oscillate according to the electric and magnetic field, perpendicular to the both. Perpendicular to each other, electric field vertical and magnetic field is oscillate perpendicular to this, and both are perpendicular to the direction of propagation of a waves. Okay. Now, this electromagnetic waves by means of spark discharge. So, Hertz observed that high voltage spark across the detector loop were enhanced. That means when the high voltage is applied in atomic gas, so when the emitter plate was illuminated by the ultraviolet light from an arc light. So in this experiment, when the emitter, that means the metallic plate, is illuminated by the ultraviolet light, that means when the ultraviolet light is incident on a metallic plate under the high voltage, at the time what happens? When the light is incident on a metal surface, the some electron near the surface of a metal absorb the enough energy and attacked by the positive ions in the metal surface. What it says that at a high voltage, suppose the ultraviolet light is incident on a metallic plate. So what are the electrons on the surface of a metal? Absorb the enough energy from the incident radiation. So what are the light is incident from this? This electron already lies in surface of a metal, absorb the sufficient energy. To overcome the attraction of the positive ions and gains the energy, already these electrons are bound with the positive ions of a metal. So when this electron near the surface of a metal absorb the energy from the radiation, and when its energy is more than the energy associated with the attractive force. So at that time these electrons are emitted from the metallic surface. After gaining the sufficient energy from incident light, the electrons escape from the surface of metal into traveling space. So during the experiment of the electromagnetic waves, now the Hertz observed that at high voltage is applied between the emitter and collector, and when the ultraviolet light is incident on a metallic surface. At that time what happens? On this metallic surface, electrons are already present on the surface of the metal. This electron absorb the energy from the incident light. when this amount of the absorbed energy is more than the energy associated with the force of attraction by the positive ions. That means after getting the sufficient energy from the incident light, the electron escaped from the metal in the surrounding space. So this effect was first observed by the Hertz. Right? Not he was performing the experiment of the photoelectric effect. He is experimentally produced the electromagnetic waves, but he observed that the electrons are also emitted from the metallic surface when the ultraviolet light is incident on the metallic surface. Clear this? After that, the next scientist is the Lenard. Lenard's observation regarding the photoelectric effect. So there is only for understanding to clear the concept about the photoelectric effect. Right? This question never asked. Explain the Lenard's experiment, explain the Hertz observation. But this type of the experiment clear a concept about the photoelectric effect. And after that, what are the observation? We have to discuss. This discussion is important for the 2 marks question. Okay. So explain the Lenard's observation regarding the photoelectric effect. So aspect of the Lenard's experiment is shown in the figure. Here the 2 metal conductor, one is the cathode, second is the anode. So as shown in the figure, 2 metals electrodes are kept at opposite ends inside a evacuated glass tube. There is the glass tube. Here the 2 metal electrodes. There is the evacuated glass tube. This. The 2 metal electrodes are kept at opposite ends inside a evacuated glass tube. Right. The one electrode is known as the cathode, that is known as the emitter, denoted by C, and other electrode is known as the collector, that is the A. The potential difference is applied between the collector, between the cathode and collector. That is our cathode, that is known as the emitter. And there is the collector. Anode is collector. Because it collects the emitted electron, therefore that is known as the collector. And that is known as the emitter because here the electrons are emitted from this electrode. Therefore that is known as the emitter. And that collect the emitted electron, therefore that is known as the collector. Okay, here the 2 metallic electrodes are kept at opposite end in an evacuated glass tube. Now, one electrode is known as the cathode, that is the emitter, denoted by C, and other electrode is known as the collector or the anode, denoted by A. Potential difference is applied between C and A, that means the cathode and A. A quartz window is provided in this tube. There is the quartz window, this. Through which ultraviolet rays are incident on a cathode. Here the ultraviolet radiation is incident on a direct cathode plate or the direct emitter plate. So what's happened? When the ultraviolet rays are incident on a cathode plate or the emitter plate, so already the free electrons and some electrons are bound with the nucleus. This electron gains the energy from incident ultraviolet rays. When the gaining energy of the electron is more than the binding energy, so electrons start to emit from this cathode or the emitter. Right? And this emitted electrons are collected by anode. Now listen. A quartz window is provided in this tube through which ultraviolet rays are incident on cathode and photoelectrons are emitted. Now, anode A is kept at positive potential, is kept at positive voltage with respect to the cathode C. with respect to the cathode. There is positive, there is negative, therefore your positive voltage. So due to the anode is positive, what are the electrons emitted by the emitter having the negative charge? This electron are attacked by the anode. So as a result, all the emitted electrons are attacked by the anode, that means the collected by the anode. And therefore anode is known as the collector. And therefore, the flow of electron takes place in the circuit and current flows in the circuit. Current flows in the circuit. Again, what's happened? When the anode is kept at positive terminal with respect to the cathode, so emitted electron by the cathode are attacked towards the anode. There is the flow of electron take place towards the anode. And this electron passing to the outer circuit and forms the electric current. Forms the electric current in the circuit. Now, when the UVAs incident on a collector, on an emitter is stopped, that means we stop this window. No ultraviolet rays are incident on emitter. At this time what's happened? The current flowing through the circuit also stops. Current flowing through the circuit also stops. So it shows that to produce the flow of electron in the circuit, here the ultraviolet rays are necessary. Here the incident of the ultraviolet rays on a cathode is necessary. If no UVAs are incident, so no current flows to the circuit. Therefore, for emission of the electron, the UVAs is required. And Leonard also observed that, or the Leonard studied that the emission of the photoelectric current with the potential difference on emitter and frequency and intensity of the UVAs. Again, the Leonard also observed that the effect on photoelectric current due to the potential difference on anode and the frequency and intensity of incident light. So that is the Leonard's observation. First, the description of figure. As shown in the figure, two metallic electrodes kept at opposite end in an evacuated glass tube. One electron is known as the cathode or the emitter, denoted by C. Other electrode is known as the anode or the collector A. The potential difference applied between the cathode and anode. Right? Here, the quartz window is provided in this tube through which the UVAs are incident on cathode. The electron gets the energy and photoelectrons are emitted from the circuit. When the anode is kept at positive potential with respect to the cathode, so there is the flow of electron take place and current flowing to the circuit. When the UVAs are stopped, the current flowing to the circuit will also stop. So from this, the Leonard also observed the effect on photoelectric current due to the potential on the anode and the intensity and frequency of UVAs for the incident light. Clear? Okay, just we discussed about the Lennard's observation and Lennard's experiment. Yes, we kept the emitter as positive voltage with respect to the cathode. So all the emitted electrons are attacked by the anode, or the emitter. As a result, the flow of electron take place in outer side. We also discussed that it is stop the incident ultraviolet light. So emitted electrons are also stopped. Right? After that, the Lennard studied how the photocurrent changes with the potential of the emitter and also the frequency and intensity of the incident light. Yes, we make the frequency and intensity of the incident light, what are the change occurs in photocurrent. Right? We have to also discuss this in next theory as a characteristic of photoelectric effect. Okay. Now, before it, we also discussed the one more experiment, that is the Hurwitz experiment. Explain the Hurwitz experiment and its observation. For that purpose, in 1888, Hurwitz connected a zinc plate with negatively charged zinc plate with electroscope. What is the electroscope? Already in chapter 1, we defined to detect the charge, the electroscope is used. Electroscope is the device which detects the charge. In electroscope, the two plates are given. As the charge is detected, so this charge is now transformed, these two plates. If the charge is negatively charged, so both are repel. If the both are positive, also repel. Therefore, to detect the charge, this type of the instrument that is known as the electroscope is used. Okay. So the Hurwitz in his experiment, he connected the negatively charged plate with the electroscope. Here directly we studied or we described or discussed the observation taken by the Hurwitz. So Hurwitz observation. First is when the UV light was incident on a zinc plate, it lost its charges. So first there is the negative charge. When the UV light is incident on a negatively zinc plate. So what's happened? The electron, negative charge, that means the electron already present on a zinc plate. So this electron absorbs the energy from the incident light, and when its energy is more than the binding energy of this electron, so this electron are emitted. Therefore, the number of electrons on the zinc plate is decreases. Number of electrons are decreases, therefore the positive charge is established on a zinc plate. So as a result, the electroscope is connected, here the repulsion force takes place due to the positive charge. So it shows the photoelectrons are emitted, or the electrons are emitted from the zinc plate due to the incident of UV light. Clear? So there is a first observation, when the UV light was incident on zinc plate, it lost its charge. That means the negative charge is decreases due to the emission of the photoelectrons. He also repeated this experiment by second. Initially, when the UV light was incident on a chargeless zinc plate. In second experiment, he takes the zinc plate without charge. That means the neutral zinc plate. Number of positive ions and number of the electrons are equal. Therefore, the total charge on a zinc plate is 0. In this situation, when the UV light is incident, so here there is the no free electrons. All the electrons are bound with the nucleus. But due to the incident of the UV light, this bound electron absorbs the energy from UV light, and when its energy is more than the binding energy of the electron, this electron start the emission. The emission of the electron takes place, therefore the electron emitted, therefore zinc plate becomes the positive. Therefore, the positive charge is increased. Again, a second observation, initially when the UV light was incident on chargeless zinc plate, it becomes the positively charged. Because what are the electrons? They are bound in binding energy or with the positive ions with nucleus. So this electron gains the energy or absorb the energy from the UV light. And when its energy is more than the binding energy, these electrons are emitted. As a result, the photoelectrons are emitted. Photoelectrons are negatively charged. So negative charge is decreased on zinc plate, therefore the zinc plate becomes the positive. Clear? Okay, thought. What's happened if initially the zinc plate is positive? So third observation is that when the initially zinc plate was kept positively charged. Zinc plate is kept positively charged. So UV light was incident on it. The positive charge on the plate is increases. Because again the same thing. Here initially the zinc plate is positively charged, therefore the number of the electrons are less compared to the positive ions. Therefore the positive charge is initially established on a zinc plate. In this situation, when the UV light is incident on a zinc plate, what's happened? So what are the less number of the electrons gain the energy from incident UV light? Again the same situation, when this absorbed energy is more than the binding energy of these electrons. So electrons are emitted from the zinc plate. Therefore, the number of the electron is decreases. Therefore, the positive charge on the zinc plate is increases. Positive charge on the zinc plate is increases. Hear this? So here we discuss what the Horvaths. Perform the experiment in three different conditions. First, he takes the zinc plate is negative, ultraviolet light is incident. Therefore, the amount of the negative charge decreases, that means the positive charge increases. In second case, we take a zinc plate without any charge. That means the neutral zinc plate. In this situation, when the UV light is incident on a zinc plate, so positive charge is established on a zinc plate, which shows the emission of the photoelectron take place. And third, initially zinc plate is positive, and we incident the UV light on this positively zinc plate, so the positive charge on the zinc plate is also increases. So this three observations suggest that the negative charge on the zinc plate is decreases due to the incidence of ultraviolet light. It shows the electrons are emitted from the zinc plate. That therefore the photoelectron takes place. Photoelectrons are emitted. So he observed that from this observation he concluded that when the UV light is incident on a zinc plate, the negatively charged particles are emitted from the plate. So he makes the two conclusions. First conclusion is that when the UV light is incident on a zinc plate, so negatively charged particles, that means the electrons are emitted from the zinc plate. Now the second observation is that he also concluded that when the frequency of the incident radiation is less than the some minimum frequency, at that time what's happened? The photoelectrons are not emitted. Again, he also concluded that when the frequency of incident radiation is less than the minimum frequency, the photoelectrons are not emitted. It shows that to emit the electron from the zinc plate or the metallic surface, the light with the sufficient minimum frequency is required. If the frequency is less than this minimum frequency, in that case, the photoelectrons are not emitted. That means the photoelectric effect is not observed. So that is the Horvath's observation from the experiment in three different cases, and its two conclusions. Here is first is the positive charge increases. That means the photoelectrons or the negatively charged particles are emitted. Second, if the frequency of the incident light is less than the some minimum frequency, the photoelectrons are not emitted. So here From this we can know that for the photoelectrons, the light must be incident on a photoelectric surface or the photosensitive surface, and the frequency of this incident light must be more than some minimum frequency. Otherwise, the photoelectrons are not emitted. Clear this? And this minimum frequency is known as the threshold frequency. It's known as threshold frequency. We discuss about the threshold frequency next.